Hello dear students, in this video I will guide you step by step on how to use a cathode ray oscilloscope or CRO, which is one of the most important instrument in electronics lab. This video will help you understand how to connect a signal, adjust the settings and observe the waveforms properly. Let's get started. First, let's understand what a CRO is. A CRO is an analog instrument used to visualize electrical signals. It displays voltage as a function of time, helping us see waveforms like sine, square, and triangular waves. It does not store signals like a DSO, but it gives real time output with high accuracy. Now let's look at the front panel of the CRO. It divided into several sections. You can see here. This is CRT skin where the waveform is displayed, and here you can see the vertical section controls the vertical position and volt per division. This is the horizontal section control the time base and horizontal position. We can using this knob we can change the horizontal position, and this knob is for time base knob. This is for time per division, and here you can see here the trigger section helps stabilize the waveform, and you can see these two for connecting the probe or signal. This is the input terminals. Let's now go step by step on how to use a CRO. First, I will power it on. This is the power button. Okay, and wait for the beam to appear as a small dot or line on the screen. Okay, you can see two lines are there. One is for channel 1. This is two channel CRO. This is channel 1, also called as X channel, and this is channel 2, also called Y channel. Using the vertical knob, I can use I can change the vertical position. Here you can see for the channel 1, and using this knob for channel 2. And I will connect this probe to any of this channel. This is called the CRO probe. As one side is the BNC type connector. Here you can see, and another side is pedal clip, and this is the probe tip. You can see I will connect it to the channel 1 for this video, and I will take the signal from the inbuilt calibration signal. Here we can get we will get 1 kilohertz 2 volt peak to peak signal here. So I am going to connect it here. So you can see a signal as I am using the channel 1. So here I will select only the channel 1 for this case, and you can see the signal is not stable. So using this trigger section, and I can stable it. First, shift this knob to channel 1. Okay, and you can see the signal is not stable, and if it is not stable, then you have to using this knob. You have to using this knob. You will stable it. You can stable it. Okay. Use the volt per division knob to adjust the amplitude scale using this, and if use the time per division knob to adjust the time base. This control how much time each horizontal division represents. You can see the value is given here. I will tell it in detail later. Here you can see two another knobs are given here. One is the focus knob, and another is written here INTN. This is for intensity. Use the focus knob to sharpen the waveform. You can see, and intensity to control the brightness. Okay, but never keep intensity too high for long. It can damage the CRT. Now we will measure a signal. Suppose you are observing a signal. This is a square wave, and count how many vertical divisions the signal covers. You can count it 1 and 2, and then multiply it by the volt per division, because in the vertical direction we will count the voltage. So how many division it covered? This is 1, 2, and then I will multiply it by volt per division. Here this knob indicating, here you can see, this notch, this is indicating to the 1. That means each division will count as 1 volt here. So 2 volt, 2 division into 1 means 2 volt. It is give the peak to peak voltage. I am counting from this peak to this peak. And for measuring the time, count how many horizontal divisions for one cycle. Okay, this is one cycle. If I count it, it start from here, then it will complete here. Okay, so using the horizontal position, I will adjust it. Okay, then I will count it from here. So it covers 1, 2, 3, 4 and 5 division. It covers 5 division. So 5, then I will multiply it by the time per division. Here the time per division is indicating 0.2 millisecond. Here you can see 0.2 millisecond. So 1, 2, 3, 4, 5 into 0.2 milliseconds mean 1 millisecond. So this is the time, and if you convert it into frequency, then f is equals to 1 by t. As the time is here in millisecond, then it will be, when I will convert it into the frequency, then it will be in kilohertz. So 1 by 1 equals to 1, then 1 kilohertz. And you can see the signal here given signal is here already given, it is in 1 kilohertz. You can see it. So in this way we can measure the time, and by getting the time we can calculate the frequency, and also we learn how to calculate the amplitude. If I require to measure 2 signal at a time, then I will connect another probe in this channel 2, and we will use the dual mode. Here you can see. So this is our second channel and this is our first channel. Okay. So this is really very simple to analyze a signal. Some common mistakes students make. Please note that: not grounding the probe properly, using incorrect scale settings, forgetting to set trigger causing waveform to move, high brightness leading to permanent screen burn. And that's it. You have just learned how to use a CRO step by step. The more you practice, the easier it becomes. And thank you for watching, and keep exploring. Thank you.